here we are on page 713. So that means that you've watched the warm-up video and have completed the warm-up. And now you are here on 713 to work through and talk about what a complement is with probability. So on 713, about halfway down, you're going to see find the probability of the complement, and here is your definition of complementary events. They are two events in which either one or the other must happen, but they cannot happen at the same time. So for example, a coin can either land on heads or not land on heads. The sum of the probability of an event and its complement is 1 or 100%. So let's look at example number 3 together right below that. So it says, find the probability of not rolling a 6 in example number 1. Not rolling a 6. Okay, well, you know on a number cube there are 6 numbers. And if you're not going to roll a 6, that means 5 out of the 6. So you're going to see that right here. 5 out of the 6 is not rolling a 6, right? So your probability of not rolling a 6, 5 of the numbers out of 6 of the numbers. Okay, now we have found that probability. So now think about its complement, meaning what's the probability of rolling a 6? And so you're going to see right next to it here, the probability of rolling a 6 is 1 out of 6. So this fraction. And so now these are complements of each other, because if you add these two probabilities together, it equals 1. So again, the probability of not rolling a 6 on a number cube is 5 out of 6. And if you think about its complement, so the probability of rolling a 6 is 1 out of 6. And again, these two probabilities add together to equal 1. So let's try one. Got it in letter E here. So this says a bag contains 5 blue, 8 red, and 7 green marbles. A marble is selected at random. So what's the probability that the marble is not red? Not red. So we see here in the story that 8 of the marbles are red. And so I'm going to write that down. And I'm putting 8 out of 20. Now, the reason why I'm putting 20 is I'm adding these marbles up. So 5 plus 8 plus 7 gives you a total of 20 marbles that's in that bag. Now, there are 8 red marbles, right? So that right here, this fraction, is the probability of picking a red marble out of the bag. Now, I know I answered that first, and it's actually asking you, find the probability the marble is not red. Great. If we know 8 of the marbles are red in the bag, that means how many are not red? Well, 12 are not red out of the 20 total. And so you have found its complement. 12 are not red out of the 20, but 8 are red out of the 20. And remember, these two here equal 1 or 100%. Okay, so with us finding the probability that the marble is not red, right here, let me box this in. This is truly where our answer is, right here, 12 out of the 20. But again, since we're talking about complements in this section, we understand the complement of not red is red. 8 are red out of the 20. Again, these two add together to equal 1 or 100%. Okay, let's try another one. So we're going to go to page 714. And in the guided practice there, number 4 is another example of a complement problem. So in the guided practice at number 4, it says the probability of choosing a go back one space card in a board game is 25%. Describe the complement of this event and find its probability. So 25% of the cards in the board game are this go back one space. So think about that as a fraction. So 25% is represented by 1/4, right? So 1 out of the 4 cards is a go back one space card. So now what's its complement? What's its complement? Which means what percentage of cards are not the go back one space? What percentage of cards are the other cards in the game? So if 25% are go back one space, wouldn't the complement here be 75% of the cards are different, right? They're not the go back one space card. And that's 3 out of the 4 of the cards. So these two added together, 25% plus 75% equals one whole. You understand that the go back space card, there's 25% in the game that are like that. The complement, the other side of that, 75% are not the go back one space cards. So 75 plus 25 equals 100%. Okay, let's try. I'm going to have you go to we're going to go to the independent practice. And we're going to look at number 5 on independent practice. So this says here, refer to the table on air travel at selected airports. Suppose a flight that arrived at El Centro is selected at random. What is the probability that the flight did not arrive on time? Write the answer as a fraction, decimal, and percent, and explain your reasoning. So we're looking at the flight that's arriving at El Centro right here. And if you notice in the table here, at that airport, the arrivals, the percent on time is 80%. So we can write that to start with so we understand what the table is telling us. 80% of the flights arrive on time. Now, the question in the story is asking you what's the probability that the flight did not arrive on time? So really what you're doing is finding the complement to that. So then 20% do not arrive on time. Okay, you found the complement. 80% of the flights arrive on time based on what the table is showing us here. So that means the complement of that to equal 100%, 20% of those arrivals at the airport do not arrive on time. 20% is your answer. Okay, let's keep going. So let's go. And this is going to be on page 716 at the top. We're going to look at number 7 and number 8 here in the bowl of jelly beans. So it says 1 jelly bean is picked without looking from the dish. Write a sentence that explains how likely it is for each event to happen. So it's going to ask you about the probability of getting a black jelly bean in number 7. It's going to ask you in number 8 the probability of getting purple, red, or yellow. So first off, let's take a look at how many jelly beans are in this bowl. Go ahead and count right now on your paper. So hopefully you came up with 20. There's 20 total jelly beans in that dish. And so then let's look at each color. So count how many purple there are. And write that down. Count how many are red. Count how many are green. And how many are yellow. And hopefully one's kind of tucked in there with the purple. You should get 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's actually a couple of them tucked in there. So there's 10 purple jelly beans in that dish. Red, those stand out a little bit more. There's 3 of those. Green, there's 2. And yellow, 1, 2, 3, 4, 5. And so that should equal 20 altogether. So the probability of getting a black jelly bean, well, we just looked at all the different colors in there. There's no black jelly bean in there. And so when it's asking for you to explain how likely it is for each event to happen, you can say the probability of getting a black jelly bean, it will be impossible, right? We talked about that number line yesterday. And since there's no black jelly beans in that bowl, that has a 0% chance of happening. So the probability of getting black is 0%. It will be impossible to get a black jelly bean. Okay, number 7, all set. Number 8, the probability of getting purple, red, or yellow. So we add these together. So when you see that word or, you're taking all 3 of those colors together. Purple is 10, red is 3, that gives you 13, and another 5 yellow gives you 18. So that means here you would have a probability of 18 out of 20 if you were to pick a purple, red, or yellow jelly bean. And if you reduce that, this goes with yesterday's lesson. If I cut that in half, it's about 9/10, which means you have a 90% chance of getting one of those 3 jelly beans there. And so you can say here, thinking about that number line, it will be likely, right? Because we're really close to 100% certain. We're at 90%. It will be likely to get purple, red, or yellow. Okay, so really, I'm going to underline here, we're looking at, with these probabilities, when we explore it and talk about it and find those probabilities, we're looking at the likelihood, okay? And so again, going back to that number line, we talk about something being impossible at 0%, and we also talk about here in number 8, something likely to happen close to 100%. Okay, so let's talk about a complement again. So we're going to keep going here, and we're going to go to the bottom of the same page, so 716, number 11. And so here, what you're going to see is some cards, and it says circle the pair of probabilities that does not belong with the other 3 and explain your reasoning. So on these 4 cards, you see either a decimal and a fraction, a decimal and a percent, a fraction and a decimal, a percent and a fraction. And so you have to figure out what's going on with each of these cards. So let's talk about the first one. You have 625 thousandths here. Well, what is 3/8? We want to make these, so we're comparing the same thing. We want to be able to compare 2 decimals here. So let's talk about 3/8 as a decimal. So go ahead and take your calculator and divide that out. So do 3 divided by 8. and see what you get for a decimal. And hopefully you see that 3/8 is 0.375. Now we're comparing that to 0.625. These are both on the same card, right? And now I have both of them in decimal format. So we've been talking about complements as part of the lesson today. And so why don't we see if you take these two, if we add them together, do we get one whole or 100%? Let's see if these are complements of each other. So again, go ahead and take and add these two values together. And hopefully when you do, you see that this equals 1. This is 100%. So this card here, these two values are complements of each other. Now that's what we need to look at for the remaining 3. So now look at the second one. On this card, you have 38 hundredths and 62%. So let's take this 62% to a decimal. So think about moving the decimal 2 places to the left. This would be 0.62. And then add that to 0.38. And again, let's see if these are complements to each other. Add these two together and see if you get 1. And you should 0.38, 38 hundredths plus 0.62 or 62 hundredths absolutely give you 1 and 100%. These two values are complements of each other. Okay, keep going. 7/8, let's take that into a decimal format. So 7 divided by 8. And you should get 0.875. Now add that to hopefully its complement here, 0.125. Add those and see what happens. And here again, it equals 1 and 100%. So far, these first 3 cards, really, these all go together. Let's check this last one. So you have 70% and 1/3. So let's, since we have a percent and a fraction, let's take both of these to decimals also, since we've been doing that with the first 3. So 70% as a decimal, 2 places to the left, right? 0.70, 70 hundredths. And then 1/3. 1/3 is a fraction that has a decimal that repeats itself. 1 divided by 3 gives you, 0.33, and it would just keep going, okay? That 3 is just going to keep repeating itself. So now if you were to add these two together, if I just stop this at 0.33 and I add these two, I'm actually going to get a value over 1. I would get, sorry, just got interrupted for a second, 1.03. That means this is 103%. So these two values are not complements of each other. So this card right here does not belong due to, when we compare it using decimal format, they are not adding up to equal 1 or 100%. All the other ones, all the other 3 are adding up to 1 and giving you that complement that we've been talking about. Okay, we're going to do one more together, one more. So let's go down to extra practice on page 717. And we're going to look at number 21. There it is right there, last one. So here, of the students at Grant Middle School, 63% are girls, and the school newspaper is randomly selecting a student to be interviewed. Describe the complement of selecting a girl and find the probability of the complement. Write the answer as a fraction, decimal, and percent. So we know 63% are girls. So you're looking for the percent of boys because it says describe the complement of selecting a girl. Well, we know 63% are girls. The complement would be the percentage of boys. So what percentage would you want to put here that you could add together and get 100%? And so think about that. What percentage of boys would that be? And so hopefully you see that if you had 37% of boys, that's the complement, because 37% plus 63% would give you 100%. So here, this 37% of boys is its complement. Now it says fraction, decimal, and percent. There's the percent as a decimal, 0.37. And as a fraction, you're talking 37 out of 100, 37 hundredths. And I can't reduce that anymore. That's it. Okay, so there wasn't a ton of examples with complements in the book. There was a few, but we needed to take the time today just to finish lesson 1 out and practice that and look at a couple other probability problems that you would come across. And so now what you're going to do, if I go back to the agenda, because that's it with the bookwork, you're going to just practice. And so you'll see at number 1, BuzzMath, and there are 2 here. So exploring the probability of a chance event and calculating outcomes and probability. So when you go into BuzzMath, it'll be the top 2 in your assignment list. And those are the 2 that you will practice through the remainder of the hour. And so once you're done, that will tie up math for today. And so Wednesday, right, Alex at home. And then on Thursday, when we meet you back on video, we will start looking at lessons 3 and 5. We're going to combine those together over a couple of days and learn about experimental and theoretical probability. So we'll see you back on Thursday. Have a great hour finishing up your BuzzMath practice with probability, and we'll talk to you soon.